All right, today we are going to talk about measures of both central tendency and dispersion, which are two different things. Notice I've got them separated here into different boxes. 3 learning goals. We want to be able to calculate measures of central tendency for a given data. We want to be able to calculate measures of dispersion for a given data. And then we want to be able to use that information to create a histogram based on our data. So, measures of central tendency, you know these out already. They tell us information about the center of the data, hence central tendency. First measure of central tendency is the mean. Now, you've been doing means since middle school probably, but this notation is probably new unless you've taken a stats course. These are our symbols for the mean. This one we just read x bar. This one is mu, it's a Greek letter. So x bar and mu are both symbols that we use to represent the mean. And we find the mean by taking the sum of the data, so adding it all up, and dividing by the total number of data pieces. So you all know how to find a mean. That should be pretty easy. So when you see x bar or mu, remember that that is what it is asking you to do. The median also tells us what the center of the data is, but it's the number that's in the middle of the list when the data is ordered from least to greatest. So the most important part of calculating a median is putting the data in order first. Finally, the mode. The mode is the number that appears most often. Remember that there could be just one single mode. There could be no mode if all of the pieces of data appear the same number of times, or there could be multiple modes. So if there's just 2 pieces of data that appear 3 times and everything else is 2 or less, then both of those would be the mode. So those are our measures of central tendency review for all of you. Measures of dispersion. Some of this is review, some of this will be new, but this tells information about how spread out the data are. So the first measure of dispersion is the range, and most people know this. The range of the data, the spread of the data, is simply going to be the difference between the highest and the lowest data values. So you take the maximum value and you subtract the minimum value. That's going to give you your range. Then there's deviation. Deviation is the difference between a single data entry and the mean. Because we're saying how far does that piece of data deviate from the mean. So that's why we call it deviation. It's the difference between the mean and that piece of data. How far off is it is what we're trying to figure out. Now, this next one you don't hear talked about a lot, but you'll probably see this notation more than you'll actually see its name, and that is the sum of the squared differences. This is found by adding the squares of all of the deviations. We've used this summation before, back when we did the binomial theorem, but what you're doing is for every piece of data, you are taking that piece of data, subtracting the mean, and then squaring it. And then again, this notation means sum. It means do that for all of them and then add them all together. Now, the reason that we find the sum of the squared differences is because of the variance and standard deviation. Variance is the actual mean of the squared differences. So, meaning we take the squared differences and we divide by however many pieces of data that there were. So add all the sum together and then divide by however many pieces of data you had. The standard deviation is a measure of how spread out the data is. And this is the formula. This is a lowercase sigma right here. This is the symbol that we will use most often to represent a standard deviation. Notice that what we have here is the same as what we had here, except we're using the x bar instead of the mu. Now, standard deviation, if you look at this top, the numerator, that is the square root of the sum of squared differences. Because all these, x sub 1 minus x bar squared plus x sub 2 minus x bar squared, that is this. You've added together all of the squared differences. So all we're going to do is take that sum of squared differences, we're going to square root it, and then you also square root n, where n is the number of pieces of data. So essentially, because both of these, the numerator and denominator, have a square root, all this really is, because variance, you took the squared differences and you divided by the number of pieces of data. So divide sum of squared differences by n, which is your number of data pieces. So to find the variance, we took the sum of the squared differences, we divided it by n. Now notice we've taken the square root of top and bottom, which just means that all standard deviation is the square root, and I wrote variation of course, is the square root of the variance. There, turn that variation into variance. So notice how this is like one step at a time. If you find a single deviation, then you find all the deviations and square them and add them up. Then you divide that by n. Then you take the square root of that. So it's one step at a time, working your way down in order to get to the standard deviation. Final definition is histogram. You've done histograms before. They're a type of bar graph where data is grouped into intervals of equal width, meaning that the spreads are the same. The number of data values in each interval is the height of the bar. Now, one thing with histograms is that you don't put space between the bars. So shove them up right next to each other. All right, so we're going to take an example here, and we are going to now find all of these different measures of central tendency and dispersion that we talked about. So here's our data. It's actual high temperatures in Columbus over a 10-day period in April of last year. So here's all of our different highs. Notice the variation that we have between them. So the mean means we're going to add all of those up, and we're going to divide by the number of pieces of data. It says 10-day period, so there are 2, 4, 6, 8, 10 pieces of data. You do need to show your work here. So finding the mean, you need to add all of those up first. So you can use your calculator to help you. Add all of those up. Hopefully you get 669, and then we divide that by 10. So the mean here is going to be 66.9 degrees. Now the median, again, our data has to be in order first. So I'm going to do that first. The lowest temperature that I see on there is 54. And I see that twice. So I like to cross them out as I go so that I know I've used it. Then there's a 58, 60, 62, then 69, 73, 74, 82, 83. So we've used all of our pieces of data. Now we can find the median by crossing off and working toward the middle. So I'll cross off 3 first, so that gets those, then another. And so I'm left with these 2 pieces of data in the middle. Now, I picked this one on purpose because you have to know sometimes the median will just be one number, and if that's the case, just write it down. But sometimes when you're crossing off, you end up with 2 in the middle. And when that's the case, you have to add them together. So take the 62 and the 69 and then divide by 2. So you essentially find the mean of the 2 middle numbers. So that's going to give us a median of 65.5 degrees. Mode, number that appears most often. So 54 appears twice. As I check, there's nothing else that appears twice. So 54 is going to be my mode. Range, remember, is maximum value, take away minimum value. So I've already got the data in order. That helps me. 83 minus 54 means that my range is a span of 29 degrees. Now this one, the sum of the squared differences. Here it would take forever to write all of this out. So I'm going to show you exactly how I want you to write this. So we take the first data point and we subtract the mean. So our mean is 66.9. So first data point is 54 minus 66.9 squared. Then I do it for the next one, which happens to be the exact same data point. So yes, you have to repeat them because each individual data point has to be represented. Now, you're going to do that for all of those data points, but it is very tedious to write all of it out. You can see I would next do 58 minus the 66.9 squared. I am just going to have you use ellipses. So do at least the first 2. Here I did 3. Then do dot, 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 and then show what the last one would be. So the highest value here is 83. So we'll do 83 minus 66.9. Now, obviously, you are going to do all of this in your calculator. I would make sure that after you have the data entered, before you press enter, that you double check to make sure you didn't hit a button wrong, because you can see it on your graphing calculator. So check them all. 54 minus 66.9, then another 54, then the 58, then the 60, then the 62. So pause this for a minute because I need you to actually try this, to work this out in your calculator to make sure you know what you're doing. Do not forget the squareds and the plus signs between. So go ahead and enter all this data, pause it, and then come back to see if you get the answer right. All right, and I double checked my answer. So if you do not get the same thing as me, so you should get here 1062.9. So that's going to be the sum of the squared differences. Now remember, starting with the sum of the squared differences, the next ones are just steps. So all you do to find the variance is take the sum of the squared differences and divide by the number of data points, which is 10. So my variance is going to be 106.29. And then finally, to find the standard deviation, all we do is take the square root of the variance. So our standard deviation should be about 10.3. Finally, to draw a histogram of the data, it tells us we need to use 4 intervals beginning with 50 to 59. Remember, these intervals have to be evenly spaced. So if the first one is from 50 to 59, the next number is 60. And since this spanned up to 59, this next one has to go up to 69. So we'll go up that way. So I just need to record here how many pieces of data are in each of those intervals. And of course, when you pick your intervals, you need to make sure that it covers your entire range, lowest to highest. So from 50 to 59, 54, 54, 58. So there are 3 pieces of data in that first interval. From 60 to 69, I'm looking up here, 60, 62, and 69. So there are 3 in there as well. 70 to 79, I've got 73 and 74, so just 2. And 80 to 89, I also have 2. When you make a histogram, make sure, first of all, that you label the axes. So the left side is going to be the number of days with that temperature. Over here on my horizontal axis is temperature, and I say 50 to 59, 60 to 69, 70 to 79, and 80 to 89. So 1, 2, 3, 4. I don't need to go higher than that because my highest data point is 3. So here's my first one. My second one has the same height of 3. Then the next ones both have a height of 2. Now, it's hard for me on here to draw this straight. Please, please, please try to be as neat as you possibly can here. If you're trying to distinguish between the heights, you can color them different colors if you want. Like sometimes I'll do this one in stripes and this one in polka dots and this one over here I might leave and this one I might completely color in, but you can somehow distinguish between your various intervals. So there is our histogram, and that wraps up our measures of central tendency and dispersion. Stay classy, North.